the stage to Juan Antonio García from Fsas Technologies, and also remotely Nakajima Satoshi from Fujitsu, connecting here from Japan. They are going to talk about long-awaited Fujitsu Monaka and also Red Hat Enterprise Linux, the new era of efficient HPC. Thank you so much.
Thank you. We are sharing with you some interesting information straight from the source, from Japan. But first, let me share with you some few words, just two things. First, it's about our name. Fsas Technologies is not a new company, or maybe yes, but is a part of the Fujitsu company. It's the name that Fujitsu select for the brand, for the data center products area or line. And from since this year, we have a new name, we have a new brand name, and we provide better solutions in a agile way to our customers, because we can make a focus work in the data center solutions from Spain, and it's not just a way to say that, but we can prove it, because in the last year we bid for the 3 major HPC infrastructure projects in Spain, and we won them all. And the renewal of the Cesga supercomputer, the new HPC infrastructure data center in La Rioja, in el Valle de la Lengua, and the BSC Gigafactory here in Barcelona. And the second one is about our relationship with Red Hat. We have a strong relationship with this vendor. We use the Red Hat Enterprise Linux and also the open source branch Rocky or Fedora as our certified improved solutions or Linux stack for our primary servers and also for our HPC infrastructure solutions, and not just HPC, but also for AI enterprise infrastructure as well, and also for our quantum emulation solutions. We use the 20 years relationship with Red Hat to provide to our customers the better solutions. And with more further delay, I'll hand over to Professor Nakajima-san from Fujitsu Japan, that we talk to you about our new ARM Professor Monaka.
Yes. All right, hope so. All right, yeah. Thank you very much for coming along. Yeah, thank you very much for joining everyone to our Fsas Summit today, well, Fsas conference today. My name is Satoshi Nakajima. I'm belonging to a Monaka Processor Development Division in Fujitsu Research Japan. So today, I'm going to have a short presentation about Fujitsu Monaka processor next generation stuff, and also some roadmap for Fugaku next and next generation HPC targeting to 2030. So before talking about Fujitsu Monaka, let me overview our company Fujitsu a little bit. Fujitsu, yeah, especially for Fujitsu Research, we have a key digital technology target market in 5 categories. Yeah, in the middle of digital technologies, of course, AI. Now AI is sitting for anything, for business, for work style, almost all society needed. And to enable AI and leverage AI, we have 4 categories: computing, network, data security, and converging technologies. Fujitsu Monaka is belonging to the computing categories and developed by Fujitsu Research. Let me talk about Fujitsu Research. So we have been developing a research office in big region, 5 regions in worldwide. Yeah, we have been operating in 5 big regions, of course, including Spain. Well, we have Fujitsu Research Europe in Spain as well. And yeah, Fujitsu Monaka processor is mainly developed in Fujitsu Research Japan in hardware. And for Monaka software, Fujitsu India Research and Fujitsu Japan are working together. Talking about Fujitsu processor histories, we have very long history of developing processors. And well, for all generation, we have already investigating what is needed for the processor for next generation. So especially in HPC, high performance computing tiers, in 2011, we released the RIKEN K computer HPC, which was marked as the #1 benchmark in top 500. And also in 2020, we released the Fugaku HPC in RIKEN. This is another #1 benchmark HPC in 2020. Even for today, some of benchmark is still #1. So, talking about Fujitsu Monaka, sustainable AI HPC platform. Fujitsu Monaka processor is a successor of A60FX, which was used for RIKEN Fugaku HPC system. So Fugaku was the first processor to use ARM V8 architecture in HPC market. We are continuing ARM architecture roadmap. So Fujitsu Monaka is a V9 based CPU series. So talking about Fujitsu Monaka, let me talk about design principle and philosophy for Monaka. When we define the Monaka specification, as I say, Fujitsu Research is always thinking what is needed for next generation computing. Definitely next generation computing, AI is needed. AI is a main requirement. But think about AI development. AI is starting from, for example, small CNN, DNN, and now LLM, large language models. But it is developing further agentic AI from LLM. So think about agentic AI. This is not only for LLM acceleration, let's say transformer acceleration. We need general workload acceleration as well as LLM acceleration. So these two are completely different workloads needed in the computer science. But to make it very nice convergence for next generation, we redefined the microarchitecture level and build out processor. That is Fujitsu Monaka. So let me talk about Fujitsu Monaka processor overview. Fujitsu Monaka value proposition is mainly 4 points. First, high performance. We are achieving high-speed computing centralized on AI workload, about 2 times faster than competitor CPUs. Next one is power efficiency. So even you have a very nice powerful processor, if the power budget is more than you expect, that doesn't work, and that is not a sustainable solution. And so we successfully implement Monaka processor to have high performance as well as very nice power efficiency. And also safety and security. Well, we have a very long history of making processor from mainframe and mission critical and HPC. So safety, security, and also reliability, that is the heart of processor design in Fujitsu. Of course, Monaka does. And lastly, ease of use. We keep using ARM architecture, which user like you can leverage ARM v9 software ecosystem very easily. So talking about power efficiency in a Fujitsu Monaka processor, we have very unique 3D many-core chiplet architecture. So let me explain about a little bit about that. So power consumed in processor is all about square of voltage. Yeah, this is very simple physics. So in the right-hand side, you can see the red line. This is standard processor. VDD, this is a voltage used for a processor. So if you increase frequency, you need to feed more voltage. This is a very natural thing. Everyone is doing that. So that means power is exponentially increasing when frequency is going up. But in our Fujitsu Monaka processor, we could successfully reduce the VDD in processor itself. That means our power curve is green one below. So even in a high frequency range, our processor, Monaka processor, is smaller power consumption compared with red line, the other processor trend. So Fujitsu Monaka is a series, not one-shot product. 2027 in the middle, we are planning to release Fujitsu Monaka processor in the world. This is absolutely first 2nm implementation for HPC market in 2027 era. And of course, it's not only one product. We have already committed Fujitsu Monaka X processor, planning in release 2029. This Monaka X processor already has a design win as a main CPU for Fugaku Next HPC series. I will explain a little bit later. So talking about the Fujitsu Monaka server, I have been explaining Monaka processor, but probably you are user, so you are thinking how is the server. We have been preparing the software stack. Thanks of using ARM v9 ecosystem and instruction set architecture, user can deploy a lot of ARM v9 open source software asset running on Monaka. And also Fujitsu, we are testing open source stack running on Monaka, and in some places tuning and releasing to let customer reading more better performance running on Monaka. And of course, in the operation system, we are supporting major Linux distributor, Red Hat Linux, of course, and SUSE and Ubuntu as well. So in the last, let me talk about a little bit about the future supercomputing. So talking about Fugaku Next, this is the successor of Fugaku HPC, which was installed in 2020 in Kobe, Riken. So the next Fugaku Next is intending to be released in 2030. And the development goal, we have 3 goals. One is made with Japan. This is the same concept of Fugaku. And secondly, technological breakthrough. Because in 2030, the computation node and requirement is moving from general purpose HPC to AI for science. So we need more acceleration in AI side, as well as conventional classical HPC workload. The target is 100 times application performance compared with Fugaku. And sustainability and continuity. Of course, we have a lot of software assets running on Fugaku HPC. So, of course, yeah, it's a good reason to reuse them running on Fugaku Next. So we decide to keep using ARM architecture for Fugaku Next as well. So this is a very simple design target overview in a Fugaku Next. As I say, in a total performance, 100 times faster than Fugaku. It is leveraged by both Monaka X processor and NVIDIA GPU. Monaka X is keep using for Scala portion, and for AI acceleration, especially for training, NVIDIA GPU is heavily used for that. And we can achieve in total 100 times faster than Fugaku HPC. So talking about Monaka X processor, this is still very early stage of concept. So apologize, only one slide we can present you today. But what we decide to use for Monaka X is at least using 1.4 nanometer process technology, which will be the advanced cutting edge in the 2030 era. And keep using ARM architecture, keep using ARM v9 architecture, and extending our capability to ARM v9 SME, scalable matrix extension from SVE. And also for power efficient and reliability. Yeah, this is a second generation of Monaka processor. So we are using second generation 3D many core and low voltage implementation and so on. So power efficiency is always our DNA to make Monaka processor. So talking about tight connection, tight integration between Monaka X processor and NVIDIA GPU. Well, in 2030, just a PCI Express connection does not make sense because it does not have any data coherency between CPU and GPU. So thinking about CPU strengths, of course, as you know, CPU is very good at latency sensitive, complex workload, and well, any source code in the world can compile and run on CPU. So this is pretty much general purpose, can do anything. But GPU has another strength, which means massive parallel data processing. This is very, very heavily used for AI training and AI inference. But if these two partitions, CPU and GPU partition, are working differently means using dedicated memory space and isolation of the memory, it does not realize big performance. So NVLink Fusion, this is IP coming from NVIDIA. Actually, Fujitsu and NVIDIA are working together to implement NVLink Fusion IP in the Monaka X. That makes enabling data coherency between Monaka X memories and NVIDIA GPU, which makes more bandwidth and lower latency in heavy AI traffics. So not only NVLink Fusion, Fujitsu has a strategic collaboration in the AI domain with NVIDIA's. Of course, part of that is licensing NVLink Fusion IP from NVIDIA to Fujitsu for Monaka X use case, but it is not only that. CUDA and AI software ecosystem, Fujitsu are working together with NVIDIA to work in Fujitsu Monaka and Monaka X platform. So when Monaka, you don't have to wait until Monaka X. Even in a Monaka server, when it is available in 2027, we can offer Monaka with NVIDIA GPU with full CUDA software stack, which make much easier for you to use NVIDIA CUDA ecosystem running on Monaka platform. So next week we have a ISC 2026. I think some of audience has already booked the flight to Hamburg in Germany next week. This is a big event, so we have also Fujitsu booth in there. So if you have a chance to visit our booth in ISC 2026, our Fujitsu staff are joining that. So we are very happy to discuss and help you to understand more about Monaka. Thank you very much and enjoy the rest of your session. Thank you.
So thank you so much. Questions from the audience? While the audience is still warming up, I'm going to ask you a question. So I'm not sure if it's already disclosed or if we have this information somewhere available. But I was wondering how many NVLinks Fusion will be connecting each processor in the Monaka X.
Excuse me, we'll the connection for a while, so if there was some question or comment,
yes,
we couldn't.
Okay, so the question was how many NVLinks Fusion will be connecting Monaka X once it's available?
How many NVLink fusions?
Does it work?
Yes.
Okay. Oh, it is still, hi, this is Satoshi Nakajima speaking. This is still under discussion between NVIDIAs. But we are planning to have enough NVLink Fusion lane to satisfy the target bandwidth between CPU and GPU. Probably we can say some data point in maybe 2027 or 2028. Not today. Sorry for that.
That would be great. Okay, do we have more questions? You're being shy today. Okay, so please, thanks again to Fsas. Oh, there's one question. Sorry.
Thanks. Will there be any changes in compilation tools to utilize these processors? Can we just... Will we need any new compilation flags to compile onto these processors?
Yeah, that is very good question. So probably you are user of A64FX. Thank you very much for keep using Fujitsu. In the Monaka and the Monaka X generation, we changed compiler strategy. We used to have a Fujitsu compiler for our Fujitsu system, but from Monaka generation, we changed the upstream first strategy, which means we are upstreaming our technology into GCC and LLVM community. So even today, if you download the latest GCC, GCC version 15 and LLVM version 21, you can use Fujitsu Monaka option. And we are committing to keep enhancing and maintaining it. So just a simple answer is just use the latest GCC or latest LLVM. Then you can enjoy the latest performance in Monaka.
Thank you.
So thank you so much. Please join applause for the people from Fujitsu and Fsas. Thank you.